Last question in the paper, question 12. Many germ-killing antiseptics are based on phenol. Table shows germ-killing power of some phenol compounds. Okay, you've got a whole pile of phenols. First question, suggest one way in which structural features increase germ-killing power of phenol compounds. Okay, so I'm going to bring this back up so I can look at these properly. I'm trying to get that just so I can see the bottom one of the trichlorophenol. No, okay. Right, that's a chlorine down there. Okay, right. So let's kind of block out for a start. This is the phenol. So none of this matters in any of them because we're looking for changes to this. Okay. So if I do that, I'm left with, right, okay, how am I increasing the germ-killing power? Now, obviously, phenol is given as 1 versus phenol because relative to itself, it's 1. Okay. Right. So we've got all of them are increasing down here. So let's look at what's changed. So this one here has gone up, has added a methyl group in, and it's gone up. So I'm looking for similar kind of things. Here I've got an ethyl, 7.5, and here I've got a propyl, and it's gone up to 20. So 1, increase carbon chain length. Now that is a connected carbon chain, so you can say alkyl, because that's what it is. What you can't see is increased number of branches, because no, this is the same branch, it's just got bigger. So be careful with that one. 2, well, 2 I think is quite obvious as well. Let me just get a different colour. I've got 1 chlorine here, there's 2 chlorines, and here's 3 chlorines. So the second thing I can do is increase number of chlorines. Okay, right, moving on down. Oh, sorry, but it's just not a helpful mouse at the moment. Okay, the names of the phenol compounds in the table are derived from the structures. You're given the rules for naming. Okay, so the OH is assigned as being carbon 1 on the ring, so let's call that carbon 1. Okay, ring can be numbered clockwise or anti-clockwise to assign numbers to the other atoms or groups. The numbers should be assigned so the lowest possible numbers are used. Okay, so we've got, if this is 1 and that's 2, the numbers would go 1, 3, 4, 6. Okay, if I go the other way, I go 1, 2, 4, 5. Right, so it's got to be the second way. So let's wipe out these ones. Okay, so I now have my carbon numbers. I have a 6 in here, just don't need to use it. Okay, so I'm going to go anti-clockwise for my numbering. If 2 or more identical atoms or groups are present, use one of the prefixes. Okay, do we have that? Yes, we do. We've got 2 methyl groups, so I'm going to have a dimethyl. The names of the atoms or groups attached to the ring are listed alphabetically. Ignore the prefixes for alphabetical purposes. So what we've got here is a chloro over here, and we've got methyl. Okay, I would assume we're okay with our alphabet here, so this chloro is going to have to go first. So we've got 2 chloro, 4, 5, dimethyl, phenol. There we go. Okay, in different methods of producing phenol, in the early 1900s, phenol was produced by the following method. So we've got benzene with some sulfuric and some sodium hydroxide, giving you phenol, and sodium sulfate and sodium sulfite, sorry, and water. Okay, calculate the mass of phenol in kilograms produced from 117 kilograms of benzene if the percentage yield is 90%. Okay, I'm going to go again with proportion on this one. So 78 grams gives me 94 grams. I'm working from 117. Doesn't matter that it's kilograms, I'm just going to stick kilograms on the end. So to get my ratio that I'm going to work with, I'm just going to do 117 divided by 78 and then multiply that by 94. Okay, it means that 117 gives me 141. That is 100% yield. Okay, so that is your theoretical yield, and you may have written it that way round. Okay, from that I need to get 90%, so just multiply by 0.9 gives me, so 90% is 126.9 kilograms. Or round it 127 because it's given us a whole number in that one. Okay, last question. Phenol is now used is usually produced by the Cumin process. We've got a Cumin hydroperoxide, there we go, to give us phenol. We've got hydronides here, but you'll notice that over the top of the arrows, they're being used as a catalyst, so they're not part of the final product set. Name the other product formed. Okay, so I'm just going to highlight here. Oh, sorry. Right, here we go. So here's your phenol. Okay, all of this is phenol. So let's work with this. You're like, right, okay, so this has to come out as phenol, and I'm going to take out this as phenol. And now I'm going to be left with what I'm going to have as my kind of end product, my other one. CH3 bonded to an O, but that's going to have to be a double bond for that to work for the numbers. And now it says name it, so you're not going to get it for that. That is propanone. End of question.